Yeah, we're good, Sagar. Yeah.
Awesome. Yeah, Mita, you can start.
Okay. The problem is rotate an array. I'll go to the problem statement. Given an array, rotate the array to the right by k steps, where k is a non-negative. When you see the input, nums are 1, 2, 3, 4, 5, 6, 7. When k is equal to 3, the output becomes 5, 6, 7, 1, 2, 3, 4. That is the last three elements, that is 5, 6, 7 comes at the start, and the remaining elements are pushed back after 7. Similarly, if you see the second example, that is -1, 100, 3, and 99, we need to rotate the last two elements, that is 3 and 99, such that they come forward and the remaining elements are pushed back after the last element, that is 99. The constraints here is one. Firstly, the maximum number of elements in the array could be 10 to the power 5. And this is like from negative to the highest number, that is the second constraint. Now here they have also mentioned the follow-up section. The follow-up section question is, could you do this in place with one extra space? So first I'll start with a brute force solution, like what I think of it, and then we can go ahead and optimize it. And if anybody has any additional thoughts or any other way of solving this, we can discuss that as well. Are we good with the question so that I can start explaining the solution?
I have one question. Is that applicable only, is that only for ascending data set, or can we have like some sample data set not in an ascending order? I see the given two example, the example data set is in an ascending order.
Yeah, I mean, the second one, if you see this one, 399, I mean, it's not an ascending order, it becomes descending order. It's basically, it says that we need to rotate the elements from the right, like whatever the elements that are at the rightmost of that array. If there are two elements, so we need to make sure that we rotate in such a way that these two elements come ahead, irrespective of ascending and descending order.
Okay, got it. Yeah. Okay.
So basically, what I understand from this problem is that you need to rotate the rightmost element. That is the number of k times that is already given to you. Like for example, I'll just run through this particular array here. K is equal to 3. So first step of rotation, based on how they have explained, is like first 7 comes ahead, and 1, 2, 3, 4, 5, 6 are aligned after 7. Then we pick up the second element, 6, and then 7, 1, 2, 3, 4, 5 is aligned after 7, and then we pick up the fifth element, and the remaining elements are aligned after we have picked up the first three elements. That is basically 5, 6, 7 comes ahead, and remaining 1, 2, 3, 4 are aligned after 7. So that is the way how they wanted to get it rotated. So the approach one that I think of it is, what I would do in this case is run a for loop through each and every elements in this array, correct? And then whenever I have the first element, I'm going to use an additional space here. So I'll create an array of same length as nums. And then whatever elements that come across, like first element is 1, right? And the index of 1 is 0. So what I would do is I would add the index plus the number of elements, that is 0 plus 3, that is 3. So the first element 1 will be placed in 3 location. Second element, I get it, that is now i's value is 1. Right, I'll just write it out. First element, the index was 0. So 0 plus 3 make it 3. So I'll place the element at 3 location, that is array of 3. I'll add 1 there. Then I'll traverse to the second element, that is 1. 1 plus 3 is 4. So at fourth location, I'll add the element 2. Then I'll proceed with 3. Third element, I mean, the location, the particular index of that particular element is 2. So 2 plus 3 is 5. I'll add 5 to the array of 5. Then I'll proceed further to the index 3. 3 plus 3 is 6. So at 6th location, I'll append 4. So in this way, the first 4 elements are added to the appropriate location in the array. But the moment I go ahead with the 5th element, that is at location 4, 4 plus 3 gives me 7. That is when I'm out of bounds. That is, that becomes greater than the actual length of the array, correct? So at that point, when I know that the element is greater than the number of elements in this particular array, what I would do is 1 plus k, and I would mod it with the number of elements in the array. So in this way, when I do a mod, that is 4 plus 3, that is 7. 7 mod the length of the array is also 7, that is 0. So then what will happen? 5 will come at this position. Similarly, when I proceed with I becomes 5, 5 plus 3 is 8. 8 mod the length of the array is 1, then 6 will be placed at one location. And if I proceed ahead, now the length of the array, I mean, I've reached the index as 6. So 6 plus 3 is 9. 9 mod of the length of the array makes it 2. So 7 is placed out here. So at the end of the loop, I have the array in a proper rotated format, for which the code is here. So in this fashion, what will happen? I am using an additional space. So the space complexity would be O of n. And the time complexity will also be O of n, because I'm rotating through each and every element of the particular array that is given to us. So this was the first approach. Do you have any other approaches that we can discuss, or should I proceed, or we can just take some time and solve it? Or if there is any other question, then I can explain again.
I was just thinking, like, the formula which we just put on, like, is it something very natural, or it just thing like we have to, I mean, I don't know, memorize it? I mean, is there any easier way, very intuitive way of approaching the problem rather than cramping this formula which we just wrote on line 26?
Yeah, I mean, while solving this, the first thing that came into my mind, it was rotating an array. Then it's better to have a separate array, and then as and when I keep on iterating, I can add those elements to that particular array. So that was the thought that came to my mind while doing this particular problem. But there is a better way also, for which I did see a YouTube video, and there is a better way that you can solve this in O of 1. But this is what I thought of, and I did it.
So to answer Aditya's question, actually, Aditya, if you just note down the indexes, and let's say if whenever we are trying to make a right shift operation, it will be, let's say in this case on line 16, it could be the 7th index, right? And then 8th index. So whenever we try to take a mod with the length, it is always the interval of the length of the array. So even if you see, if you perceive the length in this way, like 0 to 6, then again everything repeats from 7 to 14. 7 to 13. Then again everything repeats from 14 to 20. So this is almost same as when we write binary digits, there we have one or zero to represent them. So it's mathematically we can say that it's not a formula. Basically, it's just an intuition to divide any range with the mod, because 7 will be exactly divisible. So anything mod 7 will be
Zero,
0. So that brings you back to the first index of the array. So it's basically creating the interval. Any time whenever you want to create the interval, this is the way to create the interval.
Yeah, makes sense. That makes sense. Yeah, I think it's yeah, on the similar line. I think when this comes about the rotation, right? I think if we start thinking on the lines of mod and getting the remainder, how we can utilize in rotation, right? I think that can help to build the logic.
Yeah, and sometimes what happens is like one of the way is it is also helps us to add a guard condition as well. For example, if the numbers of length is in one of the problems that I've seen, that if the number of elements are more, for example, there are 7 elements and the number of k is given as 8. So that also helps us to add a guard condition in some problems also, while it helps us to determine like whether it is within the range or not. And then, yeah, I mean, we can do that based on determining the interval after doing mod. That is one thing that is, I mean, generally whenever we have this interval issues or whenever we have this in place rotation, that is one technique that we can apply.
So I've seen one approach to this problem, which kind of felt a little bit more intuitive to me. I mean, this explanation of the formula, the equation, it really makes sense now. Because at first I was holding this in my opinion, like how does it strike to you and when you do the interview, right? So it's probably not that obvious, but thinking in the terms that you guys just described really helps in, you know, adding some ideas and solving the problem. But the other approach I've seen, which I felt was more intuitive, is to consider the fact that if you're rotating the array, like let's say 3 times here, the last 3 digits should appear in front, and then the rest of the array should shift to the other end, correct? So, for example, 1, 2, 3, 4, 5, 6, 7. If you rotate 3 times, then you have 5, 6, 7, and then 1, 2, 3, 4. So how one person approached this problem was, let's say we start with 1, 2, 3, 4, 5, 6, 7. They would do like a reverse of the whole array.
Yeah.
Yeah. So, for example, like that, and then they would do swapping of the elements in the first 3 positions, and then they would reverse the rest of the array.
Yeah.
But then result in something like 5, 6, 7, and then 1, 2, 3, 4.
Yeah, this is the second approach, that where you can do it in place, reverse the entire array, and then last 3 elements reverse it, and first 4 elements you can reverse it again.
Right.
Yeah, so that is in place. That is one technique that I searched for also, like what is a better way, because here if you see there is a follow-up question that mentions, could you do it in place in O of 1 extra space?
Extra space. Okay.
Yeah, so this is the technique that could be done in place, like without using an extra array. But as a brute force, you can do it with this particular implementation. Just to, in an initial phase, just to explain the interviewer that this is what you're thinking of, and then from there you can go towards a better solution of having just O of one space and doing it in place.
Right.
I can show the other solution also. Like I just saw one video and I wrote it out. So this is the solution, where you rotate the whole array, the one that you mentioned, Vinay, where you rotate the entire array. So now you have like 7 up to 1. Okay, once the rotation is done, you have to rotate the last 3 elements, right? So you rotate the last 3 elements and you rotate the remaining first 4 elements. In that way, you will get the rotated array. I mean, this is the second solution. Like, are there any questions?
So basically, this is the 2-pointer one, right?
Yeah. Basically, we are swapping it with the left and right. Like we are setting, like first time if we want to reverse it. So from 0 to the length -1, we are going to swap it. Right? We are
That's
giving,
correct.
yeah.
Yeah, that's a 2-pointer technique. Yes.
Yeah. And second is basically 0 to k -1, 0 to 2. And then later on from k, we go up to the end of the array.
The time complexity for this would be log n, right?
That's correct.
Yes, I think. Yeah. Yeah, log n. Are there any questions? Okay. Okay, I'll stop sharing then.
So shall we take 10-15 minutes for solving the problem, or is there anything else we discussed yesterday?
Sagar, I think we just talked about, but I think it's better to spend 10 minutes to think if anyone have any other thought process or to add, but it's just my thought.
How about others?
Yeah, what I'm finding is, multiple people expressing their ideas in the call. It gives new ideas for other people when you don't think of that, right? So at least I'm learning something new this way. But I'm open to ideas here.
What is the
Okay,
question,
yeah.
Sagar? Sagar, what is the question?
So right now we are just so there are two types of opinion here. We can just simply walk through the solution instead of taking time 10 minutes to solve it. So a few people mentioned that they want to solve the problem earlier and then directly come down to the meetup, and we can just discuss the solution as well as go through the problem and discuss the solution. So I just wanted to, since actually Meeta directly jump onto the solution, that's also a good way. I feel sometimes we can have good discussion, but one thing I noticed is this problem was straightforward, but if the problem is slightly complicated, we might have to take some time to approach or to spend like just to put some thoughts over it and try to solve it somehow, just to think more about the problem. So I just came back to the same question again, that if it is better to take 10-15 minutes, or if you guys want to skip the solving part and directly go through the solution, because going through the solutions will be a temporary fix or will be a short-term solution, but there is no running away from putting some thought over our by our own.
I think sometimes like 10 minutes is too much, because most of the time we'll end up in cross questioning and discussing. So that we benefit more from discussion and listening to others' opinion. So definitely, I mean, I feel 10 minutes is a little too much. Yeah, of course, if it is a hard problem, then it is completely worth. But if it's easy problem, we can have a hard bound stop. Like you can even set up a timer, right? Like online timer, like for 3 minutes or 5 minutes, because even in the interview, if we come up with a uh, thought process, like what we are going to do,
So-
actually, that will
So
be better.
Aditya, like many people might be solving the problem for the first time here. Like, so since we have already solved most of them, I think it's no big deal for me or for I know for 2 or 3 other people as well. But if most of the people are trying to look at the problem for the first time, or so even before this meetup, they have solved it for the first time, then it might take some time to come back to the context or to gain back that frame of conceptual understanding around the problem.
Yeah, that makes sense.
So maybe let's put a hard stop at 9 to 10 minutes. If it's an easy problem, we can try to just make a check if people have completed, or we can just go discuss. But feel free to chime in, and maybe if it's an easy problem, we can discuss early. But yeah, we can put some hard stop for that.
Yeah, Sagar. I mean, we can have at least 10 minutes to at least solve, because sometimes it happens like last to last session on Saturday, at least I was able to solve the problem as well along with the discussion. So it helped, because one of the problems I didn't solve it earlier. So it helps, like, and
Yeah,
along with
exactly.
that, yeah, and along with that, we can hear other people's view also. Like one of the questions I remember, like of linked list, the one that I think Vinay explained. So that is something new, way of solving it, which helped also. And in a way, we can solve the problem side by side. So
Yeah. So maybe let's have some limited time. If it's an easy problem, we can try to go through quickly, as Aditya mentioned. But if it's a hard problem, or it's slightly subtle to understand sort of problem, we can put a hard stop at 10 minutes.
Yeah, I agree with that. I think depending on whatever we agree, 5 to 10 minutes is a reasonable time to solve the problem, and definitely discussion is what we value here as a group, right? By the way, Sagar, are we following? I mean, we can also post the problems ahead of time, like, so at least people will get the time. So I was just curious, like, what list are we following? Like top interview questions?
We have already created the list, right, Aditya? I guess. Did you attend yesterday or day before yesterday?
Day before yesterday, I was not, but yesterday I
Yeah.
attended.
So the same list. Yeah, the same list. The list we prepared for 2 pointers, that it's about to end. Let's put more I'm gonna put more problems into that. So you can just put your name and whichever problems you're gonna cover in the next session, and that's how we are going ahead right now.
Oh, it's there in the description, right? I believe.
Yes.
Document
Yes.
spread. Okay,
Yeah, the
okay.
same one, the same lead code problem one, which we used to
Okay.
follow earlier.
Got it. Oh, okay. So we are putting the names in front of that. Okay. Okay, that's nice. And these are based on okay, top lead code problems. Okay, makes sense. So we just choose and
Cool.
put the name and put the question and the name, right? That's it.
Yeah.
Perfect.
Shall we move on to the next one?
Yeah. So just give me a second here. All right, let me know when you guys can see my screen. If so, I can move forward. All right. Hopefully everybody can see. So here they're saying they give us a head of a singly linked list, and we have to return true if it's a palindrome. A palindrome basically, it's a mirror of the other half. So in this case, if we start with 1, we can see a 1 here, 2 and 2, and then we see that they're mirror opposites of each other. Now, example 2, so we return true here. Example 2, we have 2 nodes, and this is not the same as this node, so we return false. And the constraints is number of nodes in the list is in the range 1 and 10 to the power of 5, and the value of the nodes can be 0 to 9. The follow-up is basically, can you do this in order of n time and then not taking any space? So do I give like 10 minutes to think about it, or how do we go, Sagar?
Yeah, let's take 10 minutes.
Okay, makes sense. Okay. Any ideas or suggestions, like how do we go about this? Okay, let me give it a try. Now, we could make use of the concept that go ahead, somebody.
Yeah, no, Vinay, it was my mistake. Yeah, you can go
Okay.
ahead.
All right. Yeah, we could just make use of the concept here that the list has to be a mirror opposite in the middle of the list, right? So I was thinking of finding the middle of the linked list first, and then somehow we would reach to the end of the other half and try comparing the nodes. So we would go till this point, and then from here we will go till this point, and then we kind of know that we hit the middle, and then we return true if all of the nodes matched until this point, and return false if one of the nodes does not meet the criteria of matching each other. Any questions on the technique so far? Okay, so the way I would try to go and find the middle of the linked list is by using a slow pointer and then a fast pointer technique. So the fast pointer would just go to the end of the list, while the slow will go in a slower way, faster pointer will go in a faster way. And by the time I hit the faster end, I can be assured that I'll be at the middle of the list, and the slow will be pointing to the middle of the list. Now, once I hit the middle of the list, I could rearrange the chain of the nodes from here. So for example, right now the one is pointing to null here. What I could do is take a new null node and then redo the chain this way, and then keep going to the end of the list. And now I will have a new pointer pointing to the end of the list this way, and then I have the head reference of the list from here, and I would iterate this way, and I would iterate this way until I hit the null, and just match the nodes at each point. So once I hit the null, I know that these 2 points have reached the mid, and then I could just return true if none of the nodes mismatched in the due process. Any questions there? Okay. So if I follow this approach, then the complexity would be, so one pointer would reach to the middle. That's pretty much order of n, because I'm iterating through the whole list. Then I'm matching up half of the list on each side. So basically combining all the complexities, I would see the time complexity to be order of n. And because I'm not using any extra data structure to create new nodes or new lists, my time complexity here would be order of 1. Okay. And let me just pull up the code I had here so I can. Okay. So just like
it should be 2 paths, right?
Yeah, essentially, if you see it that way, we're doing one pass to determine the midpoint. Then the second pass would be to find out the similarities in the nodes. We would be traversing just half of the array. So probably that is order of log n because we're going only halfway through for the comparison. But for the initial, we're doing the full linked list. Sorry, not array.
Got it. Yeah, Vinay. Yeah.
Yeah. Okay. All right. Just like I said, the slow and fast pointer approach. We just create a slow and fast and point to the head, and then just keep iterating till we hit null for the fast pointer, and then at this at which point, when the fast is null or fast next is null, we know that the slow would have reached to the middle of the list. Then it's the second technique is to reversing the linked list from certain point. So we are employing two techniques. One is fast and slow pointer to find the middle. The second technique is to reversing the list. Then the two pointer technique where we go from one end and the other end and compare. So at any point, if we see a mismatch here, then we return false. Then we keep, so the previous will be going to the back of the list, and then the head will be going to the forward of the list. So if we don't hit this block, then eventually we return true. That's how it works. Anybody can think of a brute force way of solving this problem?
Yeah, I think brute force in terms of using extra memories is pretty straightforward, I would say.
Yeah.
Like finding the middle point and then maybe using stack to iterate and to add the elements up till the midpoint, and then just keep popping every element until you go from the midpoint till the tail.
Right. Yeah. Well, I had in the initial days, I had a different thought process. I mean, obviously allocating extra memory. So what I did was to allocate an array like that. So I would do one pass to find the length of the linked list, and then at each point I would after I allocate the array, I would just collect the elements in the array. Then I would use that two-pointer technique to validate the palindrome. That would have a cost of one pass here and then order of n memory. So that was my initial solution.
Yeah, I think that's the most basic one anyone will come across.
Right. But yeah, like I said, we could just push these onto the stack, and then the slow pointer will be here. And then we pop this node from the stack and then compare to this one, go to the next, and then pop this one and go to the next. And if the stack is empty, then we know that we're done, or the next is null, something like that.
Yeah, I guess pretty straightforward, right? Shall we move on to the next one?
Yep.
Sagar, the next one is that trapping rainwater Satish is supposed to take.
Deva, hi Deva.
Yes.
Yeah.
Just a quick thing, very quick thing on the last question. I thought just wanted to add one more thing. So I think we had both the discussion and they both were, I mean, both the solutions and they both were good. And since we covered that problem, there is one more problem, exactly same techniques, I think anybody has time, they can take a look. That is reordering the linked list, it's basically reorder the list. Basically, it's let me just check the number. It's 143. So again, it follows the same concept where you have to find the I mean, I don't know to tell, but it's on the similar lines what Vinay just explained. Only the change is basically in the third step where we're trying to compare, use a two-pointer technique and trying to compare the elements. There you just choose alternate from the two list. So in the step 2, right, you have original list till halfway and other list is reversed of the other half, right? But the step 3 is you in here in the current problem, we just compare using two-pointer techniques, right? And over there, we just choose one from each list at a time and reorder it alternatively. So it's worth looking that problem. It's a good problem, yeah.
Yeah, I think I've just solved this one, but yeah, just I would want to see it as one of the items in the problems. Definitely, let's get that on the Excel sheet, I would say.
Yeah, exactly. I mean, whatever you followed, right, Vinay?
Yeah.
It's almost step 1 and 2 are same. Step 1 is,
More or less.
find the midpoint, I think using, what is that? Some algorithm name, I don't know, Floyd or whatever, and whatever, fast and slow pointer, let's call it,
Fast
right?
and slow, yeah.
Step 2 is you reverse the second half, and only thing differs is step 3, where here you're taking two-pointer and comparing the two lists one by one.
Right.
There you just choose, you take them alternatively,
Correct.
Yeah.
Correct.
Yeah, this is I mean, it was a good problem before. It was also asked in Amazon. So we had covered the same concepts on a similar lines, but again, we can hop on to next problem.
Yeah.
This was just an FYI on the same theme.
Yeah, looks like a good problem, I guess. Yeah, maybe let's try to take this tomorrow. Aditya, maybe you can try to explain this, or else maybe
Yeah,
you
sure.
can also take this up in case.
Yeah, I can take, or anything is fine. Yeah.
Yeah, let me add to the list.
Yes, Sagar, I added that into the list.
Okay, great.
Yeah.
So next problem is Deva. I guess I'm not able to get. I guess, yeah, Satish might not be able to attend today. Yeah, I guess he did message me 10-15 minutes back.
Or can we just explain the problem and then stop from there so that tomorrow Satish can explain, or
Oh yes, yeah, that could be a good idea. Yeah. So let me go through the explanation and then maybe we can stop and try to try. So I would say we could have covered this problem, but it's a great problem and it needs to be like I feel that everyone should spend considerable time over this problem, and also it's one of the most frequently asked problem as well. So yeah, let me just pull up the problem. Yeah, is my screen visible?
Yeah, yes, Sagar.
Okay. So it says given n non-negative integers representing an elevation map where the width of each bar is 1 compute how much water it can trap after raining. So we are given a height array. So height array is basically all the elements we can see here. Each of the element will have a width of 1 unit, and the height will be whatever units given here. So initially it was 0 and the width was 1 unit. Then the height was 1, width 1 unit. Then again 0, width 1 unit. Then height 2, width 1 unit. Likewise up till this point where the height is 3 and width is 1 unit. So till end we can say that this is the terrain we have, and consider that a rain is falling vertically downward. So wherever we have some barriers both sides, we can say that the water could be trapped. So similarly here and here. So in this case, basically we have the land, or we can say the zeroth position to start with, and here whatever the height is, we have to consider that as a base. So we are supposed to compare the area of water that is being stored in each of them, and have to return the maximum the total water that could be trapped. So we can see that the width and height here is 1, so area is 1. Here it's 1, then again another one, and this is 4, then this is 5, and this is 6. So the total water is 6 units. Similarly, maybe we might need to draw it, but yeah. So this will be like we have the 4, which is tallest, and then the 5, which is tallest, and these two are at the both of the ends. So the width will so basically the barrier will start from this up till this, and whatever terrain we have, we will be just subtracting that. So from both of this, so we can compare 4 and 5 with this this particular column and this particular column. So out of these two columns, this has the lowest height. That's why the water the level of water will be up till this and not up till this. So similarly in this case, the level of water could be up to 4 till this point, because these are the two barriers which are the tallest ones. So in terms of constraint, they have given that height could be up to n, and n could be between 1 to 2 to the power 10, 2 into 10 to the power 4. And each of the so there are n elements basically in this array, and each of them could have a height from 0 to 10 to the power 5. Yeah, so I think it's easy to start with a brute force solution for this problem, and it will be very intuitive from that way. Once we have the brute force solution, it will be easier to think in any of the directions. So maybe think about 2-pointer and how can we have the brute force solution. The way I mentioned previously, that we can create the possibilities using for inside, for right, take starting from one point till having a slice up to another point. So that is something could be done here to come up with brute force solution, which is very intuitive.
Is there something like more or a little bit similar to the container with most water? I mean,
yes, yes.
Okay.
Almost, yeah. So the most important part here is trying to have an optimized approach. That's something which is tricky. Otherwise, understanding the problem, coming with brute force, it's all easy. Okay, shall we stop here?
Yeah, sure.
Any doubts in this question or whatsoever we have covered so far? Okay, cool. Yeah, so let's stop here, and maybe let's maybe we can move on to recursion. or maybe other array topics. If not recursion, then maybe we can move on to greedy or other like meeting room sort of problems. So from next to next session, so I guess it should be Thursday. From Thursday onwards, we can start with maybe meeting room problems series, since we are almost at the end of the basic 2-pointer problems. So meeting room is also a type of greedy. So maybe we can have some basic understanding of greedy from meeting room, and then maybe then onwards we can take basic greedy problems, easy, medium ones. Is that okay with everyone, or any other ideas?
Yeah, sure, Sagar.
Cool. Yeah.
I
Let's
I
stop
just
here.
have